Hi everyone and welcome to this video dedicated to the MH370. During the interview with Xavier Titelman, I said that we had to watch the upcoming work of Patrick Blely and Jean-Luc Marchand. They are today releasing a new study to detail step by step what may have happened on board the MH370. For those who have read Patrick Blely's book, this former captain had clearly considered that the person at the control of the aircraft had such a mastery of the systems that it could only be a pilot and most likely being the captain himself. I completely share this vision, and this is what I had already suggested when the first version of my book was published in 2017. In this new study, the authors prefer to be more vague by designating the author of this diversion as the person. This doesn't mean, however, that the possible culpability of the captain is ruled out. No. It is a question of being more objective and neutral, because this document will be transmitted to the French BEA and investigators such as the Gendarmerie Nationale, which is still carrying out the investigation. In this study, Patrick and Jean-Luc will detail in a very precise and technical way several points of their work, what had not been done in his book. They bring here their vision of this affair with a professional pilot's point of view associated with an engineer, but above all with technical details which proved that it corresponds with all the elements at our disposal. So, some will say that this work are based on official elements that are doubtful. However, this study also provides confirmation in other ways. I'm going to present you here the main lines of this study by explaining certain technical aspects to you in a simple way. It will of course be difficult to detail everything, and that is why I invite you to read the English version, which is available on the link put in the comment of the video on the caption site, which is sufficiently well written to be understandable for most people, while allowing professional pilots and engineers to verify advanced calculations. Demonstration video are also published for this study. The authors left nothing to chance in this study, and that's what I liked when I met Patrick. His way of sticking as much as possible to the data and his association with Jean-Luc Marchand give the most convincing duo that I have seen today in this case. It is by sticking to the data that we can then tell if this data is viable or not. We do not question official data simply by saying that we do not believe the people who provide it. This reasoning seems too basic to me. You have to find glaring inconsistency to be able to say such things. Technical explanations exist in some cases, and we must consider them. In this study, the authors proved that these data are in total correlation with the performance of a Boeing 777, because in order to be able to convince the investigators and the authorities, it is necessary to prove that to them that the calculations and evaluations are within the standards and tolerances scientifically accepted. Let's talk about the radar trajectory, and first the U-turn. This point has long been the subject of much ink because the official report failed to reproduce the radar plot in the observed time. But there is also this plot of a very sharp turn that many people have interpreted as being impossible to achieve for a Boeing 777, going so far as to say that it must have been a fighter plane that shot down the MH370. This is totally false. It's simply the result of radar processing, as I have already explained in the past. I have worked with radars long enough to say that we have what we see here is perfectly normal. When an aircraft begins its turn, the radar will not notice it instantly. It will take several position readings to realize this. The radar therefore shows the plane continuing straight ahead, and after several turns of the antenna, which can take several tenths of seconds, the tracking system will suddenly update the position of the plane. The connection of these different positions will therefore show a clear break in the trajectory. I have often observed this on radars, in particular with fighter planes that turn too tight, and when they stop turning, the radar still extrapolates that it continued turned and show a plane that has overshooted the heading given to it. And after several seconds, he realizes that he is no longer turning and he corrects it. So we have an airplane on the radar that has a heading that's sometimes changing by more than 45 degrees or even 90 degrees. So this is completely normal, and Patrick also explains it in the document. The first part of the turn that we see on the radar is therefore not reliable, and we do not know precisely where the plane initiated the turn. This is why they proceeded in this way in order to determine an entry point and an exit point. All the official report said that was that it couldn't have been done on autopilot. I agree with this first analysis. However, I also said the investigators should have considered a downhill turn, which would have reduced the turnaround time, which had not been done. But when I talked about it with Patrick, he felt that we could still do it on level flight. With Jean-Luc Marchand, they reviewed the parameters and in particular wondered if, by simply moving the entry point, it could work, and it works. Another point in this U-turn highlighted in this study is the proximity of the tail ADs, which is, according to the author, would have been a factor for the pilot who would have tightened his turn so as not to run into it and arouse suspicions of the neighboring country. An ADIZ is an air defense identification zone, in which the military must identify everything within it. A plane without a transponder, like the MH370 at the time, could have attracted the attention. This point had never been done or considered before. This study, carried out on Prepared 3D and verified by computations, showed that this U-turn was perfectly feasible in level flight if it was initiated a bit earlier than the turn. It is what really happened. In my opinion, this is the most convincing demonstration of this U-turn that I have seen to date, and it is a professional pilot with long-haul experience who demonstrates it. The plot obtained is given for a turn started at 25 degrees, but in order not to overshoot the radar plot or enter the ADIZ, Patrick suggested that the bank angle was gradually increased to 38 degrees. It seems perfectly consistent to me. A turn with a low bank angle at the start means that the radar will take longer to realize that the aircraft has initiated a turn. This turn is perfectly feasible on a Boeing 777, but requires pilot skills that only an experienced pilot can have, especially since we are here at night, which make the maneuver all the more delicate. Jean-Luc Marchand had a qualified Boeing 777 pilot perform this turn on a simulator in Nantes, and he did it without any problem, in the defined horizontal line and the allowed time of 2 minutes and 10 seconds. This shows that it works. This is the video you are currently seeing here. Let's talk about fuel calculation. This point is crucial to know later during the trajectory calculations with Inmarsat data how long the plane was able to fly. At each stage of their study, Patrick and Jean-Luc calculated the fuel consumed like an airline pilot. For this, they took into account the last remaining fuel transmitted by the last ACARS message at 1702, but also the fact that one of the two engines was consuming more than the other, as shown by Rolls-Royce reports transmitted by the plane before its disappearance. The flight log, which includes the fuel forecast at each waypoint, was also taken into account to validate the expected consumption because the flight planning software takes into account the actual consumption of each engine and therefore the difference between the two engines. The weather, the winds, have also been integrated. They used Prepare3D but also a constraint assessment tool named CAT, a tool from Capsio using an improved model from Bobby Ulich from the independent group, in order to systematically check the consumption they obtained in the simulator, and it sticks. The shutdown of the systems. It is known that the transponder was shut down before the plane made a U-turn. Indeed, it was essential that the plane disappear from the radar so that the controllers did not notice the U-turn. On the other hand, according to Patrick, the tight turn required keeping the normal low of the flight control. I agree with this review. At high altitude and by night, it was safer to maintain normal flight control low to ensure the airplane was easy to fly. It was only once the U-turn had been completed that the pilot would have shut down all the generators, integrated drive generators and backup generators. As Patrick explains very well, this action triggers the start of the APU. He would therefore have forced the stop of the automatic start of the APU because he was aware that approximately 1.5 minutes after the start, this would have restarted certain systems and in particular the ACARS. As he didn't want the ACARS to emit, he therefore kept an aircraft with a minimalist power supply, the ram air turbine, the RAT. This wind turbine is deployed at the same time as the automatic start of the APU. It allows the plane to be piloted in a basic way, and the hydraulic supply is maintained since the pumps are connected to the engines, which are still running. Crossing Malaysia. It was therefore with a plane with a degraded navigation system that the pilot crossed Malaysia. The FMS being deactivated, the only means remaining is the VOR. The pilot, according to Patrick, would have first visually used the city of Kota Bharu as a landmark. The weather was clear this night. Then he would have used the Penang VOR as a navigation head. This use of VOR was something I had already considered, but not for the same reasons as Patrick. It was the flight over Penang, as we will see later, that made me raise this possibility. I will talk about it later because it is also what Patrick identified. But Patrick also identified another detail in the trajectory over Malaysia to suggest a VOR route. These are the multiple course variations. These variations already prove that the plane is not on autopilot. This heading adjustment would therefore be a desire to follow a VOR radial by correcting the impact of the wind, a basic flying method taught in any flight training school. And I can only agree with Patrick. This trajectory was piloted by a pilot. It therefore requires a pilot reasoning to understand it. And this is why Patrick's study is very interesting. The other element that also suggests a VOR trajectory, as I said, is the overflight of Penang. If the plane was following a AirNav trajectory and therefore on autopilot route in LNAV mode, the plane would have flown over Penang with great precision, but this is not at all what we observe. The plane is offset from Penang and to south. On the other hand, ask a pilot in training and he will tell you that when you arrive over a VOR station, you are no longer able to be precise because the needle sticks to the side and you have to wait for the needle returns to take a new trajectory. The higher you are, the less you will really over the VOR station, and therefore, with the MH370 being at flight level 300, the lateral deviation with Penang is therefore perfectly conceivable in this case. But not only that, the trajectory that we then observe where the plane returns to the left strangely resembles, as I have already pointed out, as a VOR radial interception that we take outbound. That's what Patrick thinks too. According to him, the pilot used the 291 or 292 radio to bring him back on the trajectory toward point Vimy. Again, according to Patrick and I, this is no coincidence. The trajectory really follows an airway without entering the Indonesian flight information region. There is therefore a desire to appear normal in the eyes of military radars while remaining invisible to civilian radars. The ping of the copilot cell phone. Patrick and Jean-Luc make a pragmatic analysis of the connection of the copilot cell phone in Penang, showing that it is completely explainable technically, since at the altitude estimated by Patrick and Jean-Luc, the plane passes well in the lobe of the antenna, but not long enough or optimally for a call to be made. The trajectory in the Strait of Malacca. Patrick and Jean-Luc went so far as to superimpose the trajectory of civilian and military radars. So, of course, some will say that there is a slight lag, but that is perfectly normal. To explain this to you, I will explain how multi-radar system works. The controller's radar image shows a single plot, whereas potentially 3 radars have detected the aircraft. We therefore have 3 plots, and these are not superimposed for several reasons. Firstly, because the detection can take place with some seconds delay. The radar do not scan the same sector at the same time, since they are located in different places. As a result, the aircraft must have moved between 2 detections. The radar system will therefore have, for our example of 3 radars, 3 different positions. It will then take an average, and it is therefore this average that is displayed on the controller radar screen. The lateral offset is also perfectly normal because the location and altitude of the radars is not the same, and the radar, not knowing the altitude of the aircraft, makes a calculation to display it at this location. So it's perfectly normal to have some deviation on both radar trajectories. This data verification work also makes it possible to verify official data and helps to give them credibility, but not only. For their study, Patrick and Jean-Luc need to precisely determine the trajectory to deduce, as they explained very well in the report, the distances covered in the time allowed, and therefore the average speed. As this makes it possible to accurately assess the fuel consumption. And Patrick had just identified some errors in the Boeing report that did not take into account the deviation from the ISA standard temperature. The trajectory reads slightly south of Vampy, which proves that up to this point the aircraft was not in LNAV. As a conclusion, before discussing the trajectory in the Indian Ocean in a future video, I have no complaints about the quality of the work of Patrick and Jean-Luc. If I can be more measured on the sequence of the shutdown of different systems, I can only admit that everything works and that everything sticks to the known data. And what I like about this work is that it was done with great rigor. Both on fuel and speed computation, everything is pragmatic and based on concrete elements. We are not here in a scenario but in an extrapolation of the data with the aim of determining the sequence of events and reconstructing the trajectory as close as possible to the known data. And it is in this that the experience of an experienced airline pilot with an ease in handling speed and fuel consumption calculation based on real Boeing manuals is essential and has too often been neglected. They are the skills that I lacked to go further in my work. I am not an airline pilot but an air traffic controller, and therefore I do not have certain skills. Combining this skill with that of an engineer who knows how to manipulate radar and satellite data, like Jean-Luc Marchand, who has worked for several years on the MH370 with Capsule, is, in my opinion, the best way to approach the reflection of the MH370. As Patrick always told me, this case is a pilot's case. And I was already convinced of this with the work I had carried out even before meeting Patrick. I have never changed my version on this point since the beginning, and I have always tried to show this whether in the lecture I have given or in my toolbox that I have published. By not directly designating one of the pilots in this study, Patrick and Jean-Luc show that this hijack was the business of a pilot. Too many elements in this case require pilot knowledge and skills. I have said this before. It is on the same basis that I say that we cannot exclude that someone may have piloted the plane at the end of the flight. The crossing of Malaysia can only have been done by someone who was flying the plane. As Patrick suggests, an aircraft in a degraded electrical condition, and it is not within the reach of the first terrorist. The U-turn required pilot skills. Navigation also required pilot skills, even more so with most systems shut down. So this disappearance is the work of a pilot, and there is no doubt for me if we finally manage to convince some detractors. Patrick and Jean-Luc's study is beyond reproach, and it is very rare when I have agreed with so many things in a study published in the MH370. On the next video, we will discuss the final major turn and the trajectory of the aircraft in the Indian Ocean and the definition of a recommended search area. And you will see that in this part, the work is also remarkable.